Okay, this is lesson 5.2, which is on relations and functions. And so the first thing that you need to know when we're looking at this is that a relation is a set of ordered pairs. So you've probably never heard that word used like that before, but a relation is a set of ordered pairs. And it could be any ordered pairs. So like in this example, this is how far your distance is after a certain amount of time. So 1 minute, 50 yards, 2 minutes, you've got 100, 3, 150, and so on. And so, but a relation doesn't just have to be time and distance. It could be anything like number of hours you spent studying and the relationship with that to what your score is on a test, or age and height, or number of hours worked and how much money you make. All of those things are all represent a relationship or a relation. And when you write those as a coordinate point, if you're talking about a relation, you always want to make sure and put them in these braces right here is what they're called. So make sure to be aware of that. So whenever you have a relation, you write it as coordinate points, you want to put them in braces like this. Okay, so that is what a relation is. Any set of ordered pairs. Anything that you can think of. Now, a function is a relation where each value of x gives one unique y value. So for example, I have y equals 5x plus 7. So no matter what number I put in for x, I am only going to get out one unique answer. So if I put 0 in for x, I'm going to get an answer of 12 out. And that's the only answer I'm going to get. I'm not going to get like 12 and negative 100. I only get one answer out. So the way I would write this in function notation, and this is something new, is I would write f, so for function, think about function, so f, and then you put in parentheses whatever variable you're using here, which in this case is x. So f of x equals 5x plus 7. So if this had been 5a plus 7, you would write f of a. But since it's x, it's f of x. So function of x equals 5x plus 7, f of x, function notation. So that's something you want to get used to seeing, and that you'll start to see in the book is when they talk about a function, they're going to use f of x instead of y. Something else that you need to know are these words domain and range. So we've talked about domain and range before, but domain is your input, so it's your inputting or your x value. So domain is always your x value, and range is your output or your y value. So like I said, if my input, if I put 0 in as my domain, then my range would be the number that my output, what I'm getting out, which in this case we said was 12. So those are domain and range, and that's important. Remember, I always remember range and y go together because G has a curly Q tail just like Y has a curly Q tail. Okay, so we've talked about relations, we've talked about functions. So now we're going to look at how do I know whether a relation that I have is a function, which means how do I know that if I have a relation that for each value of x I'm going to get one unique y value. So that's what we're going to look at here. So how do we know when a relation is a function? Well, there's two ways. Option 1 is graphing, and option 2 is mapping. So I'm going to graph first. And we use something called the vertical line test. Vertical line test. So if you don't have graph paper, then you should get out graph paper now. You could pause the video and go ahead and go get a sheet of graph paper. Okay. So we are going to graph these coordinate points, this relation, and see if it actually is a function. So I'm going to go ahead and get my x and my y axis. And I'm going to plot 3, 2. I'm going to plot 5, 1. I'm going to plot negative 5, 3, 1, 2, 3, 4, negative 5, 3, and I'm going to plot negative 2, 2. So here are my points. I don't connect them. So my range in this case are all my x values, which was 3, 5, negative 5, and negative 2. And or those were my, I don't know what I just said, but those were my domain values, 3, 5, negative 5, negative 2. My range were the y values, which are 2, 1, and 3. And I don't say 2 twice because it's showing up. So when I look at this, what I'm really asking is, for every unique input or x value, did I get one y value out? And the way you can test for that is the vertical line test. So you can take your pencil and you just slide it across. And if you only hit 1 point at a time for every vertical line, remember vertical goes up and down, then you know that it's passed. So like here's a point. Did I only go through one relation here? Yes. Now I'm going to go to the next one. Oh, I only went through 1 point with my line. Right here, I only went through one. Do another one, I only went through one. So this passed the vertical line test. So this one is a function. Now let's look at one where it's not going to be like that. So on this example, I've got, let me turn it this way. I'm going to go ahead and go my x and my y. So I'm going to plot 2, 5, 1, 2, 3, 4, 5, 3, 4, 2, 7, and 5, 1. So hopefully this is really clear to you. If I use the vertical line test now to test this, and I draw a vertical line through these 2 points, I've just gone through 2 points. That's a big no-no. Therefore, I didn't pass the vertical line test, so this is not a function. So that's not a function because I went through 2 points. Whereas this one, we're good. Each vertical line only hit 1 point. So that's one way you can test, is to graph them and use the vertical line test. The second way is to figure out if a relation is a function is to do something called mapping. So the way we're going to map here, it's like kind of like thinking about a map is you're going to make 2 circles here, and you could think about this. I guess when you look at a map, you see land. Like these are 2 different lands. This is my domain, and this is where I would put my range values. And you always want to number these smallest to greatest number. So domain is going to go in this first one, my x value. So my smallest domain is -4. And then I've got -1, which was right here. I've got 1, and I've got 2. Those are all my x values, all of my domain or input. Okay, so I'm going to go to my y now, which is my output or range. So I'm going to go ahead and put in here smallest number first, so -3, 0, 5, and 12. So the question is, does each x value give me one unique y value? So now I'm just going to connect them with a line. So I'm going to say, okay, -4, that went to 0. Okay, 2 went to 12, that gave me one unique answer there. -1 went to -3, one unique answer, and 1 went to 5. So did each x value give me one unique y value? Yes, it did. So this is a function. Okay, so let's go ahead and try this next one now. So again, it's a map, so it's like I'm making 2 continents, or however you want to look at it. So I'm going to go ahead and put in my numbers from smallest to greatest. So x value goes -3. Now I've got 2 twice, but I only write it once, 2, and then 4 goes here. Now I'm going to come over here, and I'm going to do all my y values and put them in here. So my lowest number is -3, then -1, then 3, then 4. I don't know why I changed color. I shouldn't have done that. Okay, in fact, I'm going to rewrite over there. Purple. Okay, now I changed color. Okay, so now I'm going to go ahead and connect each of those. So -3 went to -3, so I'm going to connect them. And then 2. Well, 2 gave me -1, but 2 also gave me 4. And right now you should be thinking, that's not good, because I had an x value that gave me not one y value, but 2 different y values. So right now I would stop and I would say this is not a function. Because that 2, it gave me -1 and it gave me 4, so it can't be a function. So that's mapping, or this is checking for a function with mapping. So now what I'd like you to do is try quick check, pause the video and try quick check 1 and 2. 1 and 2, it's on page 257 and 258. 1 and 2, and then hit play when you're ready. Okay, so 257, quick check 1 was the mapping. Okay, so this is what your first map should have looked like. Look right here. Okay, so all of your x values, your domain were in the first one, your range should have been in the second. So now I'm going to go ahead and connect these. So -4 connected to 0. And then we had 3 went with -2. But 3 also went with 3, and right there you can stop because we know this is not a function. Because I had an x value, an input value of 3 that gave me 2 outputs. So that is a no-no. This is not a function. I can keep going just to show you the rest of these. So 8 went to 1, and 9 went to 2. But it's not a function because that 3 went to negative 2 and 3. Okay, so let's go ahead and try this next one. Okay, so this one I had my 2 went to 6, all the way down there. And then my 5 went to negative 1. And my 6 went to 2. And 6.5 went to 0. And 7 went to negative 1. Now, here's the question. Is this a function? And some of you might be looking here at this, how 5 went to negative 1 and 7 went to negative 1. Is this a function? This is a function. So why is this a function but this wasn't? Well, I still got one unique answer for each of my x values. 5 gave me just one answer of negative 1, and 7 gave me just one answer of negative 1. So this is a function. So it's kind of like saying 2 plus 2, that gave me 4. But 3 plus 1, well, that can also give me 4. So just because 5 and negative 1 are connected and 7 and negative 1 are connected doesn't mean it's not a function. So this one is a function. Okay, so quick check 2. You had to graph them and check with the vertical line test. So this is quick check A that you should have graphed. And so if you go through here, if I draw a vertical line through each of these points, they only hit 1 point. So this first one, this one is a function. Quick check B, when you check this one, if I draw a vertical line through this point, that's good. But now if I draw a vertical line here, no, beep, 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 not a function. Not a function. It did not pass the vertical line test. Okay, now let's go on. Now we're going to talk about tables. Okay, so here's our example. We are going to make a table for this function. Notice how they wrote this, f of t, because the variable is t right here. F of t equals 0.5t plus 1. And it says use 1, 2, 3, and 4 as the domain values. And then it also says what is the range. So on this table, the way they have this set up is t's right here. That's your domain. Here's where we're going to do all of our work, and over here is f of t, which is our range values. So this is just where we're going to do our work. This is another way of setting this up. So we're evaluating this really at this point. So I'm going to put 1 in because they want us to check it out, what this function is going to give us for the values of 1, 2, 3, and 4. So I'm going to do 0.5 times 1 plus 1. Okay, 0.5 times 1 is 0.5. 0.5 plus 1 is going to be 1.5. So I put 1.5 over here in my table. Okay, now I'm going to go ahead and try my next one. So I do 0.5 times 2 plus 1. So this is 1 plus 1, which is 2. So I put 2 over here. Now I'm going to do 0.5 times 3 plus 1, which is 1.5 plus 1, which is 2.5. And I'm sure you're guessing what our next one's going to be. This is 0.5 times 4 plus, I don't know why I put 4 there, 0.5 times 4 plus 1, so that's 2 plus 1, which is 3. And so when it says, what is the range, we would want to write this. Again, you're going to put this in braces, and you would put 1.5, you would put 2, you'd put 2.5, and you would put 3. So that's a range, or our output, for the input or domain values of 1, 2, 3, and 4. Okay, so quick check 3, which is on page 259. Hit pause and then come back to check it. Okay, so you had the equation, and it didn't say to write it as a function. Like, they didn't write it as a function, they just had it still as a regular equation. So y equals 8 minus 3x. And it said use the domain 1, 2, 3, and 4. So we've got 1, 2, 3, and 4. So those are our domains, and we're going to go ahead and find each of the ranges. Okay, so I'm going to put 1 in up here. Y equals 8 minus 3 times 1. Well, that's 8 minus 3, which is 5. So then for 2, we're going to go y equals 8 minus 3 times 2. Well, that's 6, so 8 minus 6 ends up being 2. Now we're going to do 3. Y equals 8 minus 3 times 3. Well, that's 8 minus 9, which is negative 1. And our last one, y equals 8 minus 3 times 4. That is 8 minus 12, so that ends up being negative 4. So you would write that your range for this one is 5 to negative 1, negative 4. Okay, that's it. Go ahead and rewatch any parts that you need.